Honeywell is really a technology company. So we really invent and kind of create kind of the future innovations of what the globe actually needs. When it comes to optical and quantum communications, it's really about connecting the globe. So we've been doing this for decades in terms of communications with RF, and optics is really the next advancement in terms of how this is going to evolve and where this is going to look through. The quantum aspect of it really brings in another innovation, which is about cyber resiliency. And then all of this comes back to secure communications.
Honeywell have generated the processes to make reliable systems over many years. We have quite a bit of heritage in radio frequency communication systems, and Honeywell systems have been on over 80% of satellite communications missions in space. So we're taking these procedures and reliability know-how of engineering and applying it to the next generation optical systems in space. We know how to design for manufacture, we know how to keep the costs down, and we know how to meet the requirements and ensure that this harsh space environment doesn't kill the instrument.
Really, the main technical hurdle here is in building an optical payload that is capable of tightly focusing that beam and delivering a high-quality quantum state to a ground station over thousands of kilometers. And the other challenge that's present in quantum systems specifically is that you're preparing qubits, which are very fragile states of information. And so we use polarization, which is a type of orientation of light, and we prepare basically single photons in specific polarization states, and then we have to transmit them over this thousands of kilometers.
Honeywell Aerospace is actually involved in 2 quantum-based satellite missions at the moment. So there's the Quantum Encryption and Science Satellite, otherwise known as QSAT, as well as QKDSat. So they're actually quite unique from each other. So QSAT has 2 payloads. The primary payload on QSAT is actually based to receive photons from the ground. There's a secondary payload on QSAT, which is going to transmit photons to the ground. And this secondary payload is actually going to act as a proof of concept for QKDSat. So QKDSat is slightly different from QSAT in that it's only based on transmission of photons from the satellite to the ground, but it's also a full end-to-end QKD system.
The QKDSat program is a public-private partnership or collaboration with the European Space Agency. We started our work on the QKDSat program almost 4 years ago as payload manufacturers, optical payload manufacturers, and we are continuing it as of October last year as Mission Prime, which means we're in charge of the space segment, so the entire spacecraft and optical payload integration, as well as the user segment, so the optical ground stations and deployment on terrestrial networks that bridge into the space segment to create the end-to-end network. The technology leverages the principles of quantum mechanics to protect not only the data that gets generated, but also the channel that the data is transmitted on. So this is the first element of security protection. The second one is protecting the end-to-end infrastructure with the latest cybersecurity hardware or software modules available or developed by Honeywell to protect the infrastructure from side channel attacks, photon pair split attack vectors, and all sorts of other malicious interference.
What really makes the research at Honeywell so unique is that we're really at the cutting edge of deploying the quantum systems or the quantum key distribution systems that I think are going to be very impactful in terms of the quantum networking infrastructure that we'll be using in the future. You know, something that's not just on the page, but is actually real and is flying and being used by governments, but also hopefully eventually by regular people.
One of the main ways that Honeywell is trying to address both the miniaturization and robustness and manufacturability of quantum sensors is by utilizing integrated photonics. So fabricating waveguides and high-quality resonators or gratings or other devices onto a photonic chip, you can realize the same functionality that you can with bulk free space optics, but do it on a small package, and that often increases the robustness as well as the manufacturability of the quantum sensors as well.
because we're a multinational company, we're in a perfect position to actually address this global economy, but also kind of give that commercial need that has the stability that others might not. If you're relying on critical technologies that you actually need to deliver around the world, you need a company that is stable, that will be around, that can actually produce it at the volume rates and have the technology that you can actually enable. These technologies we see as foundational technologies that will really change what communications will be today and into tomorrow. You know, we've been a technology company for 100 years. We've been a communication companies for decades. We're really bringing in the new innovations of technology and communications and really paving the way for where the global strategy is going to be going.